Welcome to Study Loop.
In this problem, we are given with the reaction equation for the reaction of bromine and chlorine to form the BrCl, and we are given the equilibrium constant in terms of molarity for this reaction, Kc. We are given the number of moles of bromine and chlorine which were initially added, and we have to find out the equilibrium concentration of bromine, chlorine, and also the product BrCl. So to do that, what we have to do is we have to find out the initial concentration for bromine and chlorine from their initial number of moles. And since you're given the volume of the reaction vessel, which is 3 liter, so just using their number of moles and the volume, we can easily find the initial concentration of both of the reactants. And from there, setting up an ice table, we can find out the equilibrium concentration value, and thus we can know the equilibrium concentration for each of the reactants and products. So first step is to find out the initial concentration of bromine and chlorine. So the initial concentration, we just write Bri. For initial concentration of bromine, it will be number of moles of bromine over the volume. So number of moles of bromine is given as 0.25 mole, and the volume is 3 liter. So it will give us a value of 0.08 molar. So this is the initial concentration of bromine. Similarly, we can find out the initial concentration of chlorine, which will be the number of moles of chlorine, 0.55 mole over the volume of the solution or the reaction vessel, which is 3 liter. So it will be 0.18 molar. So now we know the initial concentration of both bromine and chlorine, and from here, setting up an ice table, we can find out their equilibrium concentrations. So the reaction is bromine plus chlorine in equilibrium with 2BrCl. So initial concentration for bromine is 0.08 molar. Initial concentration for chlorine is 0.18 molar, and initial concentration for BrCl is 0. Then the change, if we consider the change as x, then for bromine it will be minus x, for chlorine it will be minus x, and for BrCl it will be plus 2x, since the coefficient of BrCl is 2. And then at the equilibrium, we will have 0.08 minus x molar bromine, then 0.18 minus x molar chlorine, and 2x molar BrCl. Now we know the equilibrium concentration for each one, and we know the value of the Kc. So we can set up an expression for the equilibrium constant in terms of molarity. So the Kc for this reaction will be the product concentration over the reactant concentration. So we have product concentration coefficient is 2, so the power will be raised up to 2 for this one. And in the for the reactant, we have bromine and chlorine. So now if we just put our values here, so the value of Kc is given as 7. So 7 is equal to, so the equilibrium concentration for BrCl from the ice table is 2x. It will be 2x square. And then for bromine it is 0.08 minus x, and for chlorine it is 0.18 minus x. So from here, if we solve this, we will get the values of x as 0.06 or 0.56. So these two values of x are possible from here if we solve this equation. So 0.56 is not possible because this is the change in the concentration. So from the ice table you can see that x is the change in the concentration, and for bromine the initial concentration is 0.08, and for chlorine it is 0.18. So the change cannot be 0.56, which is greater than both 0.08 and 0.18. That means this is not the value of x, so the value of x is 0.06. Now just plugging in the values in this equilibrium concentrations, we can find the equilibrium concentration for each of the reactant and product. So the equilibrium concentration for bromine will be 0.08 molar minus 0.06 molar, which is the change, and it will be 0.02 molar. And for chlorine it will be 0.18 molar minus 0.06 molar, and it is 0.12 molar. And then for BrCl it is 2x, that means 2 times 0.06, which means 0.12 molar. So this is the equilibrium concentration for bromine, this is equilibrium concentration for chlorine, and this is equilibrium concentration for BrCl.